Here we're going to apply these composite functions on these sets. So to define the functions, R is a function that's going from left to right, mapping A to B. S is a function going from left to right, mapping set B to set C. The inverse is just going to be going in the opposite direction. So for example, the inverse of S would be going from right to left, mapping C to B. So when we take a look at S A, which is S of R of B, our input is B. So we need to make sure we know what our input is. Our input is B, so this is our input. And we're going to apply the R function to it. And that's going to give us 1. So what we end up getting then is S of 1. Okay, when we map 1 and apply the S function, we map B to C, we're going to end up with 2. Okay, so that is the output for S of R of B. When we are applying the inverse, we're going to start with the inside function. So we're going to start with S, and the input is going to be this Roman numeral 4. Inverse is applying the S function in reverse, so we're going to map it in this direction. So in the inverse of 4, S of 4 is going to be 1. So we end up with the inverse of R, the inverse of S of 4 is just going to be 2. And then the inverse of R, we're going to go in the backwards direction again. We're going to map from B to A, and that's going to map D. Okay, so the answer is D. So again, we can do the same thing here. We have our inside function F, which is mapping X to Y. The outside function is G, mapping Y to Z. We're going to start with an input of B. We're going to map that onto Y. So our output is 1. So F of B is equal to 1. And then 1 is going to be mapped onto Z. And our output is the at function. Okay, just clean that up a bit. That looks a little messy. So it's going to be our at function. Same thing, we're going to start for D, we're going to start with the F function. We're going to start, in this case, the input is C. F of C is equal to 3. So we end up with the F of C equals 3. That becomes the input for the G function. The G function, when we apply the input 3, the output is the hashtag. Here we're doing the inverse, so we're going to start with the inverse of G. So we need the output of G becomes the input of the inverse. We're going to go in the opposite direction. So we're going to end up with 4. So the inverse of G is inverse of G of the exclamation marks is 4. And then that becomes the input for our inverse of F. So again, the inverse of F is going from right to left, and we get an output of D. So those represents the outputs for those composite functions. When we are mapping on graphs, we can do mapping on graphs. We can actually apply the functions here and actually plug in the numbers, but we can also just use the graph. So we're going to start with the G function. For F, we're starting with the G function. The blue function here, which is a square root. The input is 9. So there's my 9 right here. The output is going to be 1. So F of G of 9 is the same as F of 1. Well, what that means is, and we can translate that back to 1. So my input now is going to be 1. And the output is going to be now on the F function. So I need to apply that 1. F of 1, the output in this case is going to be -3. Okay, so we can actually map this like this. Okay, it goes from 9 to the G, so to the back to the input. So we put it back onto the x-axis through that line y equals x. And all that line y equals x is doing is translating the y coordinate into an x coordinate to apply again. For the next one we're going to do f of 2 first. So the green function is 2. So we're going to look at 2. We're going to find the y value. When f is 2, we get a y value of 4. Okay, so it's going to map onto there. We take that y value 4, it becomes the x coordinate for the blue function, so we end up with 0. So f of 2 is what was it equal to? It was equal to 4 in this case, and then g of 4 is equal to 0. Okay, so those composite functions can be done. We can actually plug them into the equation if we want as well, but we could also just map them on our graphs to be able to take the output y and then use that new output as an x coordinate for the next successive function.